Hi everyone, this is Josh at Dyno Dad. Just wanted to quickly share some interesting test results we had doing a VVT sweep and some dyno power testing here. So the vehicle under test is a 2015 GMC Sierra L83. That's the direct injected 5.3 motor with a 6L80 transmission, four-wheel drive, and approximately stock size tires. The major power mods include a Brian Tooley Stage 2 truck cam, S&B cold air intake, and Speed Engineering long tube headers. So here at Performance Dyno, we're doing our tuning with a land and sea eddy current load control two-wheel drive dyno. So looking at that BTR camshaft, specifically it's a Gen 5 truck cam. They call it the Stage 2 V2. It's running 210 duration on the intake side, 223 duration on the exhaust, 540 lift at both, with a 111 lobe separation angle and a 14% bump on the fuel lobe for that direct injection high pressure fuel pump. So this cam is specified and designed and successfully proven to work with the stock torque converter. We've used it in this truck with no problems in other vehicles as well. So jumping into the dyno results, what we actually started with is doing an entire dyno poll with the variable valve timing target set to 0. So we just flatlined that at 0 across the whole poll and did a poll. And we received results of 392 foot-pounds of torque at the tires, 343 horsepower, and it's a pretty smooth dyno chart here. Really nothing that stands out as being unexpected. So once we got this done, we moved forward with the same poll, but moving the variable valve timing target up to 3 degrees. So this will actually retard the cam 3 degrees. The torque dropped to 384 foot-pounds of torque, and the horsepower increased to 347 horsepower. So this is kind of the behavior that we would expect when retarding the cam. Gaining some top-end power, losing a bit of low end. A little bit of a hot rodder trick in the old days, but here we can do it and have some level of control while under real-time runtime operations. So after that, we did another poll with the cam target at 6 degrees across the board. We really saw the torque drop down at the lower RPMs with a peak torque of 377 foot-pounds of torque. The horsepower did not increase at the peak power point of 347 horsepower, right around 5,400 RPM. But what you'll see in a moment is up above 6,000 RPM, the 6 degree target did in fact gain a bit of power over the 3 degree target. So here we have an overlay of all three dyno polls, the 0 degree, 3 degree, and 6 degree targets, laid together on a single sheet so we can really see how they look together. So down at 3,000 RPM, you'll see that the best torque was found with the 0 degree poll. That was 369 foot-pounds of torque, dropping to 353 with 3 degrees of retard, and then 336 with 6 degrees. The difference between the polls, as you can see, it kind of comes together up to 5,000 RPM, where really the platform at this point, this particular combination did not care what the variable valve timing was from that 0, 3, and 6 degree targets. The power was, for all intents and purposes, the same at that point. But then they begin to diverge out again as the RPMs increase, and at 6,100 RPM, we have a best horsepower of 338 wheel horsepower. That's with the 6 degree target. As mentioned, that is a little bit better than the 331 horsepower that we saw with the 3 degree target, and certainly noticeably better than 323 horsepower when the cam was zeroed out for the variable valve timing target. So what you can see here is when you have a cam that does allow the operation of VVT, it's very important to test where the particular combination is happiest and at different RPMs. So of course, what we're going to do here is take this information and build out a nice ramp for that VVT target based off of RPM to blend the results that we have here. So we're going to maintain 0 degrees up through 4,000, 4,200, and then blend that towards, let's say, 3 degrees at 55, and then hitting 6 degrees up above 6,000 RPM. So for point of reference, what we have here is you can see, I'll just go through a couple of screenshots from HP Tuners, which is the tuning platform used, 3,500 RPM with an intake target of 0 degrees. You can see our air mass is 0.8, dynamic air is 24.4. So then we'll look at the same point, but for the target of 3 degrees and then a target of 6 degrees, and you'll see that the airflow does show approximately a 4 to 5% drop. So air mass goes from 0.8 to 0.78 and then down to 24.0 for the dynamic air measurement, well, rather calculation. And then with the 6 degree target, we see the air mass drop to 0.76 and the dynamic air drop to 23.43. And we know these air measurements are pretty accurate, or these calculations are accurate, because the injector data has stayed the same and the air fuel is achieving the same target for all of the dyno poles. And what you'll see here is I have kept the throttles 100% wide open through all the poles, or it's reading 99.6 here on the scanner. And we have the same timing curve for all 3 VVT power poles. That way the ignition timing does not have an influence on the power output. And then doing a similar scan through, we'll look at 6,100 RPM with a 0 degree target. We have an air mass of 0.75, dynamic air of 40.15. That in this case, because we're looking at the higher RPM, where we saw the power gains as we added the intake cam angle or retarded the cam, that extra 3 degrees, we see the air mass increase to 0.77, the dynamic air to 41.16. And then with the 6 degree target, we get 0.77, 41.6. So a minimal gain there from 3 to 6, but definitely the right direction. And then finally, what we do is do the dyno test, which yields the best power curve overall, because down at the lower RPMs, we're targeting a cam angle of 0. We're ramping that up so that we're hitting 3, roughly 5,500 RPM, and then bringing it all into 6 degrees of retard for 6,000 RPM and above. Additional testing was done with more angle. The gains diminished after 6 degrees. And of course, what you can see if we step to the previous log, the angle is not perfect. There is sometimes a bit of wander. So we like to minimize any step changes in that target angle, so we get a nice smooth control with as minimal jitter in the cam positioning as possible. So those are the results. Final torque value being 392 foot-pounds, max horsepower 350 horse for the final pole, with everything blended together nicely. And if you have any questions, feel free to reach out. Josh at dynodad.com. Take a look at the webpage. We do have posts here, Facebook, Instagram, maybe going to dive into TikTok starting today. And we'll get this posted up on YouTube. Look forward to your comments and feedback. Hope you have a great day. Thank you.